Hello, in this video I'll be showing you a steel connection using Prota 2025, and I am using the Prota Steel 2025 to perform the steel connection for this steel pump shed, which you can see here. Now I'll be showing you how to perform a steel connection between the corbel of a gantry crane and the column connection, and also between the two rafters where we are going to use a hunch connection because of the moment connection which we found here. And also I'll also show you a steel rafter connection is for a rafter beam, and then between the column, which you can see here too. And then we then move to the base plate, where we'll also show you how to connect for the base plate, which you can see here between the base plate and then also the column. And then also for the pole lines, which we can see here between the two pole lines, and also for the side pole line, which you can also see here around the side pole line. Okay, that is fine. Let's now dive in back now to the particular model where this building was taken from the Prota 225 ProtaStructure. This is actually a steel warehouse having a crane beam on both sides. Okay, that is fine. So I'll quickly now close this particular model. Now I will not save because I'll not save because I'll work with you on that. And then we then move back and then open the Prota Steel which we have here. Now before you must export your Prota model or your design from ProtaStructure down to Prota Steel, you must have made sure that you have already finish your modeling and also performed your structural analysis, and you have checked for all your members and everything is okay. Now this is a steel pump shed that's going to carry like a crane of 20 tons, so which you can see here where I applied all the moving load. Maybe in my next video I will show you how to properly apply moving load on this software. Most people say this software don't apply moving load, but it does apply. You can apply moving load on this software. Then if you look at this, let me show you the actual model for this particular crane. Now this is the actual model for this crane, which was done with Navisworks. As you can see the crane here. Okay, this crane is to carry a 10 tons, a 20 tons load, and you can see the column bracket and the gantry beam here, which we have also modeled around here. That is fine. Okay, that is fine. So on that note, now let's now dive into what we have for today, which is the steel connection for this particular building. So I'll come now and then maximize this here. And again, so now once you've done this, next thing to do is to save, and you're sure with your design and everything is okay, and you're verified all your members are okay, no one is failing based on deflection and all that. We then transfer this now to we then come here, click on this, and then transfer this to Prota Steel, and then click on this. Then wait for that to finish up now. Just hold on for a while. Now, while this is going, we are currently running 49.9% discount on our Ekidel mentorship training. So if maybe you have been looking for a way, or there's a friend of yours looking for a way, this is the right time to join Ekidel mentorship training, which runs between now and the end of July. That is fine. And if you want any materials based on our Ekidel materials that we use for design, you can check on this link below this description, and then you can see our Ekidel store, or go to Google and search for Ekidel store or Ekidel mentorship training on your Google, and then you will see every details and also all the training syllables that you need. So right now it is not trying to do what export this particular model into the Prota Steel, which will wait for that to do what to finish up. Okay, that is fine. So once it is done, we can then go ahead and then open it up. It will just come up by itself, or most times you can also go ahead and then minimize and then launch it up. Okay, that is fine. So we can then, let's see what's going to here. Now you can see that everything has done what has been exported successfully, which you can see here. So we then move on to right now and then click on close here, and then save again, and then move on to go and open the Prota Steel. So now on the Prota Steel, now you can now see that our Prota Steel has opened, but right now nothing, there is no connection, there is nothing. So we are now going to begin for the connections for this, and we can start with the connection between the column bracket for the that is carrying this gantry beam for this screen, and then between the column bracket and the column, because that is how they are going to connect, and then from there direct to the base plate, and then from there direct to the pedestal, and then to the foundation. Okay, that is fine. So now we can now begin to do our connection for each of them. Okay, that is fine. So based on that, now the first thing to do is to begin our connection. So we can to do the connection between the corbel, which is the column bracket, and the column itself, which is the stanchion. We are going to use a hunch connection, because this particular connection here is a moment connection, knowing that this is a cantilever and all the load from the crane is going through the gantry beam, and then from there down to the column bracket or the corbel, and then from there it transfers to the column. So the connection between the column and the corbel is meant to be a moment connection. It must be a moment connection. So in that course, now we are going to use gum to column, beam to column connection, and then we are going to choose this hunch connection. Now most of my connections here have already been customized, all right, based on my own settings. Okay, now if I click on this, now I'll then click on the column, which is the main, and I'll click on the corbel, which is the secondary, and then we will have this automatically gotten here. I can see the and all everything is here. If I now click on escape and then click on this center and then rotate like this, you can see my connections here. Okay, that is fine. So with that, now everything is set already. I'll then continue with that, and then keep this way. Click on this and then do it like this. Make sure I see all the column brackets and the stanchions like this, and then zoom in like this again. So on that note, now I'll click on this again, and I'll click on this, and then on this, and I'll have that, and again this and this, and I'll have that, and again this and this, and I'll have that, and again this and this. Okay, that is fine. So that is fine. I will not be teaching about customization on that, because that takes time a lot to customize each of these, but most of people that have already enrolled for Ekidel mentorship, they must have learned this. Okay, so in that, now we can move on to the other side too here, which we have here, and I'll click on the column here, and then the stanch, and then the corbel, and again this to this here, and again I'll also have this to this here. Sorry, not there. Not that one. This to this here. That is fine. And again, we also do this to this, and again we'll have again this to this here. Okay, that is fine. So we have that. Now we are not done with performing the column connection between the corbel and the column, but I don't want to have this stiffener plate at the front of this, so I'll just quickly hold them down and then remove them. I don't want this stiffener plate. All I want is just the stiffener plate between, that is at the web of the column, because it has to be there. Then I don't want the one at the front of the corbel, which is the column bracket. So I'll quickly hold my control key and then remove, and click that, and then remove all the stiffener plate at the front, because it does not require for my design, although most times it might require, but for this it doesn't require. So I'll come now, I click now and then say what, delete. That's fine, and I'll say yes, delete that. I can see that. So we have this now very neat. Okay, we have this perfectly arranged well. So we then move to the other side too and do the same thing for the other one. Click on this, hold my control key and this, and again do the same thing here. Click on this and again, and come here, rotate like this. Make sure I see all the four. Come here, click on this, and again this, and again come here. Sorry for that. Come again here, this, and right click, and then say delete. Okay, that is fine, and say yes. So on that note, now let's now go and do the connection between the rafter and the column itself, which is the stanchion, the rafter and the stanchion. So on doing that, now this will also be a moment connection too, which I want to also use a hunch, and I'll click on this and then this, and that will give me this rafter is HEB 240, while the column is HEB 280. So in that course, again I'll click on this, and again we have that, and again the main and versus the secondary, and again the main versus secondary, and again the primary and the secondary, and then we have that. I'll move again to the other side too to do the same thing here, the main versus the secondary, and again we have that. Can see that. and again the main and the secondary, and we'll have that, and again the main and secondary, we have that, and again the main and secondary, and then the main and secondary. So we have that connection now itemized there. I'll click on escape key now, click on the connection of them, and then you can see all the connection are lined there, which you can see here. Now I want to have this because this is a stiffener plate. I want to have that for this hunch at the particular end. Now we have done for the connection between the column and the rafter. Okay, that is fine. You can see that if I rotate this by clicking on this, any of these, now we can have this done. You can see that. You can see the column spacing, and sorry, the bolt to bolt spacing, which is actually 65 from the face of this place meter, and then the bolt size is 16 mm, which is there, and that's 16 M16. Now let's now move on to the connection between the two rafters. That's the beam to beam rafters. Okay, that is fine. Now for the rafter to rafter connection, which we have here, this must be a hunch. Although for a smaller structure that does not carry much moment, you can have it to be a welding. But in this case, I'll click here right now and then click on this and then say beam to beam, and I'll click locate on the Apex hunch connection, and I'll click on this, which has also been customized also already. I'll click on this and then also for this, and then we have that. Okay, that is fine. But I don't want this bolt after this rafter. I don't want this bolt here, which I'll take off later. And I'll come again here, click on this and on this, and then we have that. And again for this we have that, and again for this we have that, and again for this we have that. Okay, that is fine. So I will now come back to here now, click on this, click on any of them now, and zoom with it like this. And I don't want this particular bolt display. I just want this bolt, these 4 bolts aligned here based on my design. I will then come now, click on this one here, and open the bolt macro, click on this now, and then click on this, and I'll say delete this, and again here and delete this, and I'll say if I say apply now, you can see that it will go off, apply, and that goes off, and then say okay. So this is what I want to have. Now from here to here is 50 millimeter, and from here down 52. Okay, that's fine. So this is what I want, just like this. Okay, so with that now, I will then repeat the same thing for all other ones which we have here. Click on this one again here, and then I'll come now and then say come here, position, take off this one, delete, and again this one, delete. So I'll do the same thing for if I say apply again, I'll have the same thing. Okay, so the same principle for all other ones there. So I'll come now and repeat the same thing for this remaining 3. Okay, that is fine. Okay, so right now, finishing the last one which we have just done just now, we then move on to, we are done with all the Apex hunch connection, which you can see. So we are done with the side pole lines, the Apex hunch connection, and also the gantry being distances. Okay, that's sorry, the corbel and the column connection. Let's now move on to the base plate here, which we have here. So I'll quickly click on this now, and then click on, although I have not really set my base plate macro, so I'll do the setting with you guys. So I'll quickly come here now, and then go to my base plate here, which I have here. I'll then click on base plates here, and I will click on this here, and then on that I will then click on this. Okay, that is fine, and I have this. Now I want to have a pin connection at this point by having 4 bolts inside the web and not just outside the web. Now this, my base plate is 350 by 350 in terms of the size, but I want to have my 4 bolts outlined here. So what I'll do now, first of all, I'll come and do what, change my plate thickness from, let me see, from 10. Okay, I want to try 10 first. If 10 fails, we'll then move to 20 thickness. So in this, I'll just say apply and then do okay. Now I want to have my 4 bolts listed here. So what I'll do now, I'll quickly come here, click on this first and hide this. I will hide this stanchion which we have here, and just to see my actual bolts on the plan view. So we only have 2 bolts now, but I want to have 4 bolts within the webs. Okay, that's fine. So I'll come now, click on this on this bolt, double click on the hole, and come like this. Now I want my bolt diameter to be what, 20 millimeter, since it is now if I'm using 20, that means invariably I'll have to change this to 20, the base plate to be 20 millimeter, 20 here for the base plate, and I'll click on what, apply, and then say okay, and then let me make it to be default. So I'll come now and then say 20 and set as default, apply and OK. And then we have that now. Just now you can see that we have that, and then we then come now and click on this bolt now, this bolt here, this hole, make that this is 20. Okay, that is fine. And I don't want bolt yet. I just want a hole because I want to use an anchor bolt and not just normal bolt. I will then come to here and then define my bolt, this to be 8.8 grade underscore bolt. That is fine. And then come here, tolerance, I can use 2 or 5. Yeah, this will be workshop. I want my grade to be 8.8, and then come here, I want this. Now come here, now I want my 4 bolts to appear within the web. So I'll come now, click on this, I'll type based on my base plate dimension, this will be 100, and here will be 60 millimeter, and I'll say update. That will change, and I'll come here. If I say update and apply now, that will change. Can state has moved. I'll come again here right now, come here and type 100, and then here will be 60, and I'll say update, and I'll say add. And on this add now, come here, edit this, add minus sign here to change the orientation of that, and then say update, and again add again, come here and then remove this one particular one here, this minus sign, and then say update. And we have 4 bolts now on different locations. I'll then come and do what, say apply, and then we'll have 4 here, and I'll click on what, OK. Then I'll come back here, right click now, and then I'll do what, show all. We have that shown now. I can choose to reduce this first to 10 or 15. Then after my design, we'll know if it's okay or not. So I'll come now and then say 10 back, and I'll click on what, again that's fine. And again we then do this now to now show our bolt. We then come to our miscellaneous here, and then click on anchor bolt. On the anchor bolt now, I'll then come now, click on this particular point here, and then we'll have our anchor bolt appearing here. Now I want to have an anchor bolt with a tag plate, so I'll quickly escape now, and then come to this place now, this pedestal. I click here and then say height. Now on that height now, I'll click on this and then rotate like this. I don't want this distance, is too long, so I'll come and click on this now, and then change my distance here to, I don't want that longer distance, sorry for that. Come here and then come here and put 0 distance, and then come here, my tag plate is to be what, 10 mm. Okay, 10 mm, and my tag plate width is to be what, 50 millimeter. And if I come now, I'll say okay, look, just put your eye here, apply, and okay, that's fine. So I want to achieve this, so we now have this now. So with that now, I'll then click on what, this, and then right click and then say show all. So with that settings, I'll then come now and then click on this particular point now. Click here, we have our click here now, we have the bolt there. And again, if I now escape again, escape. Okay, so now we will take this particular point now, we will take this like this to see the other end here, and also add our bolt to this other side. Come here and add bolt here, and also bolt here too, that's fine. So on that note, I don't like the way this bolt is, so I'll quickly come now and escape, click on this one, and then remove this particular one. Okay, that is fine. I'll say yes, delete that off, and make sure that you are clicking at the center point and not at the edge. Okay, that is fine. So we have that correct. So else your bolt will not be aligned. So in that note now, we have now added all our bolts. This is the welding thickness. Okay, that is fine. We then now come now, and now the welding thickness now, because this is 10 mm, and then this place here is 14. And then so the lowest thick, and then the web is 8.5. So my web thickness must not be more than the lowest thickness. So either equal to or that. So I'll come now, the web size, okay, is showing 8. So I'll put here 8.5, 8.5. Let me see that. Yeah, 8.5 here too. 8.5, okay, that is fine. 45 degrees, okay, that's okay. And I'll do what, say apply, okay, that's fine. So we have this now being increased. So in that note now, we have done for this base plate here. So we then do the same thing for all other ones too. The same thing, if I come again now, click on this other one here, base plate, click on this, and then come here and click on this, and then we have there, we come here, click on this now, and then modify those values immediately to what we did before. Click on this now, click on this, and then say 100, and then here 60. These settings are based on my particular base plate which I am using. Okay, that is fine. And then 100, and then update, and then say add, and then come to this add now, click here and add minus to this, and now say update again, add again, click on this and take off this particular one here, and then say update, and then say apply, and then say okay, that we have that. I'll then come to auxiliary here, miscellaneous, and then click on the particular center point here. We have that, and then we have that. We also have this here. Okay, that's fine. So I'll now rotate for the other end now. Click on this and rotate on this axis direction. Okay, that is fine. And I'll come now, click on this bolt, and then rotate again to see that point very well. Okay, that is fine. So on that now, I'll then click on this anchor bolt again, click on this point now at the center, make sure it's there, and again here, center of it, not in at an edge, center here, and then do that. That's fine. So on this now, I'll then escape again, escape, and then continue from here. Let's now go and do the pole line connection. So I'll come now, click on the pole line. So I click like this to see my pole line. Okay, that is fine. And I'll zoom in like this now, and then go to my pole line connection here, which has already been set also. Click on this, and I'll click on the main, and then the main, and then okay, secondary. Okay, that is fine. You can choose to change your pole line connection. If you don't want this, you can choose to click on this macro, and then that will open up, and then you can choose a different one which is also popular. Let me show you the one that's also popular too, to like choose for that. So when this opens up now, you can also choose this here by saying use this bracket type, and then say, if I say apply now, that will change. Just watch now, that changes to this. Yeah, most people also use, but I don't like using this. So I'll just come and do what, say angle type, and then do this here, apply. Okay, that is fine. Although you can use that based on your design. So we have done for this. We can do for the all other ones too here by coming here to click on this place here, click on the primary, and then the secondary, and then that will give us that. Okay, that is fine. If you want to change your bolt diameter, for example, I want to use 12 diameter for my bolt, M12. So I'll just double click on the bolt, and then that opens up. I'll say here 12 instead of 16. I'll say what, apply, and okay, and I'll come again here, again open this up now, and then say again click here and then say 12. I'll say default and apply and okay. That is fine. Okay, that is fine. So then we are now going to move on to the other one, which is now to show you how to connect for the side pole line. So for the side pole line connection, I'll quickly come here now and then click on the side pole line around here like this, and then we have the column and the side pole lines. So on that now, I'll then come and do what's here, which is side pole line here, and I'll click on the main, which is this, and then the side pole lines like this, and then we'll have that. Okay, that is fine. You can choose to change your side pole line the same way again, escape, and then click on the macro here, and then you can choose to change this particular one now to a different one that you want to use. Once it opens the macro, we can choose the bracket type, which is also very common when it comes to pole line, but this angle one is very common in most industries. You can choose to click on this one now, bracket, and then say apply, and then you will have this. Okay, you can start. So you can see to use any of them, either to use this or to use any of that. Okay, that is fine. So I'll come again here now, and then I can choose to do this here to this particular one here again by coming here, click on this now, and then say main, then this, and then we'll have that. Okay, that is fine. So you can choose to change it if you want to change it. That is fine. Okay, so on this now, we have then covered almost everything. So you can see how we have done my connections here. Okay, that is fine. Although I didn't go in details to show you all the settings, but that takes a lot of time. It can take almost 3 hours or 2 hours to do all the settings. Okay, but most people that have passed through our trainings have already learned all that. So this is how to perform a stick connection on this. In my next video, I will show you how to, let me see. In my next video, I will show you how to do the particular model and apply moving load for a crane in this software ProtaStructure. Okay, that is fine. If you want any of our product or material, just check on the link below and then get to our Ekidel store, or you can also search on Google Ekidel store, or go and search on Google Ekidel mentorship training, which we are currently giving a discount to this month of July. That is fine. See you on my next video, and then bye for now. Okay, bye then. Yeah, see you. Bye then. Now, before you go, if you have any question about to ask based on what I've just shown, you can do that on the comment section, and I'll also try to reply you ASAP. And if you're new to Ekidel, consider subscribing, and if you're an old subscriber, consider joining the Ekidel membership. And if you want to get an in-depth understanding about structural design using this software, or just to have first-class understanding about design of structures, you can then enroll for our Ekidel mentorship training. Bye then, and bye for now. Yeah.